Hello, everyone. Welcome to today's webinar entitled Movement Joints in Tile and Stone Installation. I'm Jim Olson with the National Tile Contractors Association. I want to welcome you and thank you for taking time out of your busy schedule to attend today's webinar sponsored by Mapei. Before I introduce today's speaker, I want to remind you that during the webinar, you'll be muted. Please use the questions area on your computer to type in your questions, and we'll answer those questions at the end of this presentation. If the audio on your computer is poor, please call the number on the invite to this webinar and listen on your phone. All of our NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are completed. This will give you easy access to watch and or share all current and past programs at your convenience. All right, here we go. Very excited to introduce today's speaker, Jim Whitfield. He's a FCSI, CCPR, LED lead app. He's the director of the technical services at Mapei. He manages a strong technical services department that provides support for Mapei's many products for floor covering installation systems and tile and stone installation systems. He's actively involved in the development of tile industry standards on the TCNA board and handbook committees, on the ANSI A108 and ISO committees. Jim is also on the NTCA National Tile Contractors Technical Committee. He's the current president of the MMSA Materials Methods and Standards Association. In addition, the Construction Specifications Institute honored Jim for his contributions to education in the construction industry and fellowship in 2001, and I'm honored to have him here with us today. Welcome, Jim. Thank you.
Thank you, Jim. It's very, very nice. I appreciate the introduction. All right, well, welcome to Movement Joints in Tile and Stone Installations, identifying and specifying proper treatment of movement joints in tile and stone. This is AIA registered. If you're a design professional looking for AIA credit, please send the information to Jim Olson, who will in turn send it to me, and we'll get you registered. You can't escape the responsibility of tomorrow by evading it today. And Abraham Lincoln said that. In other words, there's never enough time and money to do it right, but there's always enough to do it over. We'd like to prevent that. And movement joints are a huge issue in our industry. And I think this presentation will kind of highlight that to you. But me and Jim were talking about it before we started the presentation. Can't stress it enough. Either you place movement joints or Mother Nature is, but they're going to be there. All right, what we'll talk about today is first, we'll discuss the liabilities and potentially dangerous conditions that can occur when you do not install movement joints or allow for movement. We'll talk about the different types of construction joints and how they function and how they're placed, etc., and why that's relevant to movement. Movement's not just back and forth, it's dynamic, so we really have to accommodate for that. We'll talk a lot more about this. Finally, we'll look at the guidelines, or if you might, the standards, and how we incorporate those into a specification or design for a project. Yeah, you knew it had to happen. We're going to start right off with some pictures. Many of us have received calls that the tiles standing away from the building, or for that matter, it's bowed on the floor. There was an old term that we used to say a lot in fast food kitchens, and it's called quarry tile pop-up. Don't hear that so much anymore, but basically the tile expands and expands, and in some cases because of absorption and the moisture, and they actually pop off the floor and be held together by the 3 G's. I'm sure some of you have heard this: God, grout, and gravity. That's pretty much it. On the left side, you see an improperly installed movement joint profile type, and in turn caused a failure. You see the tile popping out on the right next to the movement joint. On the right, that tile's raised as well. It's St. Petersburg, Florida. Now, these are fairly not so bad climates. You get into some of the really major temperature change ones, you really have to make sure that you accommodate for this. So, was it the adhesive? Well, that's what we hear, of course, being a setting material manufacturer. No, it was the tile. The tile is glue. They actually do, and we'll talk a little bit more about that. It's really just a combination of things that are happening here, and we'll get into a lot more dynamics on that. This is a picture of an exterior facade, and you see the tile on that large wall. What you don't see so well is the tape and things or markings on the tile where they're hollow or loose. That's a 20 by 36 inch porcelain tile. I don't have to tell anybody on this call what it's going to be like if one of those come free and drop. Not safe. In this case, it was an improper mortar selection as well as not well executed expansion joints. I did not see this failure myself, but I could tell you that I frequently see failures and lack of properly placed movement joints. And one of the biggest issues I see, the joint is not clean. In other words, we got mortar 3/4 of the way up, and then we've got a sealant just capping that joint. That is not a movement joint. We'll get into a lot more about movement joints, sealants, and so on as we go into this presentation, but it has to be clean. It has to allow for the tiles to expand and contract and or the substrate. Glass tile. Unfortunately, I've got a lot of pictures of glass tile and shattering, from pools to walls like you see here, to just around escutcheons. Not easily recognized, but glass expands and contracts at a much different rate than ceramic and stone tile. It's much higher. So you really, really have to accommodate for movement joints. On exteriors, where you should be every 8 to 12 feet, I always recommend that they be about every 8 feet, period. So if you got a range and movement joint accommodation, always keep it on the low end when it comes to glass. And by far the most critical one, and I don't believe we have it in this picture here, is the perimeter. Between those two walls, that creates a lot of stress. So movement joints around the perimeter, and were needed. This is a pool. Unfortunately, it failed. And again, I've seen many of these. I had a pool over in Hawaii that Hilo, and it just sat in 8 inches of rain almost the whole time. Failed miserably, but that's not this pool. But this one, when they did take out the grout, the tiles just laid down fine. So then they put the movement joints in and reinstalled the tile and regrouted. But the one problem with a pool is something this large. When you have this much stress, that is creating stress across the whole tile plane, enough that it lifts up the tile, you may think you're bonded in some other areas, and you really could have destroyed the integrity of that bond just by the stresses that were applied in other areas. So I can't stress it enough, especially in the case of a commercial pool. Make sure you install this movement joints properly and frequently so that you don't ever have to come back and have to deal with this problem, because it's not easy to take care of after the fact, no matter what. You create issues in other areas you didn't even think about. Here's an example of popped up tile, if you might, with 3 different types, a granite, a ceramic, and a porcelain. So you can see that it isn't really specific to any type of tile. Tile pop-up can occur at any time. Wasn't an impact or anything like that. Needless to say, this tenting is not safe and create tripping hazards and just absolutely not needed. I mean, it could be accommodated for. This is a interesting one, and I think there's some videos available on YouTube if you might. But this is a store in actually Brisbane, Australia, that not only was it popping one direction, but it was going the other direction as well. Terrified the people inside the mall. They actually had shut down the mall, cleared the mall out, because they thought something was going on when they started hearing this large popping, or sound like gunshots for that matter. Not safe at all. Matter of fact, one of the guys I do belong to an Australian Tile Geeks, also posted on it. And again, they called the police, they evacuated the mall because of loud banging or tile lifting. They thought the floor was collapsing. And I might point out in this other picture, you'll notice there's carpet here on the left side. This is not a huge area of tile. Movement in all substrates can and will occur. Different joint types are suggested by the ACI, American Concrete Institute. and there are guidelines for concrete for proper joint placement. They have specific design purposes, and they're to accommodate movement and anticipate what's going to occur in the concrete. We'll get into that a lot more specifics. We'll discuss the most common types of joints and their purpose as defined by the American Concrete Institute's ACI CT-18, which is concrete technology or terminology. Contraction joint, or what many call a saw cut. It's formed, sawed, or tooled into the concrete structure to create a weakened plane to regulate the location of cracking, resulting from a dimensional change in different parts of the structure. Where we see this a lot is coming off a staircase, right? We anticipate, because that's a weakened plane within a concrete slab, that if there's deflection on a second or third floor, that it's going to crack off that corner. The odds are fairly good that it will. So very, very misunderstood. They're typically about a 1/4 inch deep, can be as much as, shouldn't be less than, I'm sorry, 1/4 of the depth of the concrete, or should be no less than 1 inch deep. So they're not necessarily going all the way through the concrete, as you see in that diagram on the right. But the intention, if there is stress within that slab, because of the weakened plane at the very top of the saw cut, it should crack there. And the odds are fairly good it will, not always though. A construction or cold joint. Now this is a heavy duty cold joint here, probably in a road actually, because you see all the reinforcing going into the existing slab as well as into the new pour. Cold joints are an issue that they're hard to determine where they're at, but they're two separate pours. They may be tied together with reinforcement, but the odds are fairly slim they're not. That means that when those slabs move differently, it's going to crack there. So really, you need to make sure that you take a good look at where cold joints are and so on, and try to plan on having a movement joint in that area. Isolation joint. Now this is a great picture of an isolation joint, and a pretty common one for that matter. And that would be where they put in the columns ahead of time. Then they'll put a footer or column support pile right around it, and eventually pour the slabs to it. That is a movement joint. That is an actual expansion joint there, as well as isolation joint. So the intention is for them not to meet, for them to move separately. As you can also see sometimes where a slab runs into a wall, and they could also be separated entirely. Or for that matter, in residential, where we used to see it a lot, was when it ran into a footing, and the footing was higher than the slab. So they are intended to move, but not necessarily create stresses on the slab next to it. But can't stress, this is truly an expansion joint. Call it isolation, but it's an expansion joint. All right, a few pictures of expansion joints. So there's a variety of ways of doing it. One picture we don't show here, and we will get into more detail a little bit, is walls. You also have to have them on walls for that matter. There must not be any reinforcement across the joint. It's an actual separation in the structure. And so in turn, we need to continue that through the finished materials. These photos, you see kind of 3 different types. 2 examples are profiles, if you might. One, a heavy commercial type one on the left, and the other on the right for a little bit lighter duty for that matter. And the other is a flexible sealant over a backer rod and quarry tile. They all perform well. Obviously, if you had a big wide joint, you aren't going to put a bunch of sealant in there if it's 3 inches wide. That's a totally different animal when it comes to those building expansion joints. But those are the types you see in airports. You see in a variety of different areas. All different ways to treat it. Okay, these illustrations are really exaggerated, but they're done to demonstrate those common types of movement, from bending to curling to shearing to in-plane movement. So, in-plane movements you see in the upper right-hand corner. That means that shrinkage is occurring, it's pulling away from itself. And this is where most of your what's the word I'm looking for? Where you're putting membranes on it, the crack isolation type membranes for in-plane movement. The one you see below that shear, you can obviously see how no membrane is going to help you there because you're creating a point load or a stress on that edge. And again, these are exaggerated, but just to give you a better idea. The thick line you see over the top, the black one, the intention is to show what a tile would happen to a tile if it was on top of it. These are all issues, and curling, we'll get into more details on that, but that's a common occurrence in slabs and creates a lot of stress on a tile. Bending's just as bad. Okay, what causes movement in a structure and or tile installations? Well, there's a variety of things. Again, there's movement of the substrate itself. We've heard that concrete can shrink. It can shrink, it can represent as much as 0.01 to 0.03%. That's a good amount of movement. In 100 linear feet, that would be about 3/8 of an inch of change. They're also known to change dimensions from changes in the moisture level of the concrete. So what you see on the right is curling. And that typically occurs because the base is still wet and the top is drying out very quickly. But this is why we see curling being such a big issue. Movement can also come when concrete slabs expand and contract with changes in temperature, known as thermal coefficient of expansion or contraction. Consider that the concrete can exhibit shearing in a joint when changes occur in structural support. So if we don't have a good compacting of the soil, if you might, underneath it, you actually have it breaking or shearing off from the slab next to it. And that's what you see here. Tile is as small and as dry as it'll ever be when it comes out of the kiln. Most tile, especially as you see it in quarry tile, when they come out of the kiln, again, they're very, very dry. From that point on, much like a brick, and they're composed of the same types of things as a brick, as it takes on moisture, it wants to expand. So according to the ISO EN 105-45-2 and 10 standard, tiles affected by moisture are typically the ones with over 3% moisture absorption. Again, they're known to grow as much as 3/4 of an inch every 100 feet. So that's a lot. So when you walk into a fast food store and you see that the toe of the cove base is pushed back into the drywall and the top of the cove base is pushed away from the wall, it's actually stress from the floor that's causing that. Again, this is what causes quarry tile pop-up in commercial kitchens. Movement joints are essential. Either you place them or Mother Nature will. You might hear me say that a few times because I can't stress it enough. Thermal expansion and contraction. Ooh, sorry. We go through a lot on the outside of a building, whether it's rain or sun, then it's cooling down in the evening, then it gets hot again. Or for that matter, where I grew up, Chicago area, where it's snowing, and all of a sudden the sun comes out, melts everything away. We got a lot of different scenarios causing the tile to expand and contract. And of course, color affects it as well. As you see this dark color on the wall, that's not going to expand and contract at the same rate as the color that's on the ground or on the sidewalk. So when they're exposed to the environment, it really can expand and contract a lot. So we've got thermal expansion as well. Moisture and thermal, two big ones. Wall expansion joints. As I said, I wanted to kind of stress this because we don't talk about it a lot. We talk about slabs and things like that. This is a mud bed type installation on an exterior wall, but in this case, it's a wood structure. It could be CMU, and there's an open joint right there. In that case, you come over the top with paper, weather resistant building paper, and it has to overlap. Then you put up your lath system, cut the lath. It has to be separated or cut. In this case, we're putting a 2-part slip expansion joint, but could also be 2 casing beads back to back and sealant right up the middle of it. So just a good example of it. The picture you see on the right, unfortunately, was taken this last year in a job in the Midwest where gauge porcelain tile had actually pushed away from the wall because of lack of properly installed movement joints. And by the way, those tiles did start falling, but side of the building, thank goodness nobody was close to it. It's believed that some of the best practices were many, many years ago and continue to be passed down through ages. They go back to the installation world, goes all the way back to Greek or Roman times. One example of long-lasting installation is the Parthenon in Rome. The Parthenon, the Roman artist installed the multicolored marble floor on a concrete mortar bed on top of a sand bed. It's said to be the small gutter around the outside of the room that allows for expansion contraction and not push into the walls. The sand bed permits the entire installation to move without restriction. After over 2,000 years, this thing has still been performing. Moving forward, tile associations in the United States started getting concerned and making changes. It goes back many, many years. We're getting a little bit more history on the movement joints, but today the people really influencing, most influential ones in standards and well, I shouldn't say most influential ones, but the ones that are really putting the documents out are TCNA and ANSI, and we'll get into both those towards the end of this presentation. Tile's not the same. It changes. When TCNA was formed in 1945, the methods and terminology for tile installation is very different than it is today. A great example of that is the tiles in 1945 were typically fairly small, in most cases mosaics. By 1984, the tile industry had advanced into larger tile formats. They're now being used. The sizes of about 8 by 8 and 12 by 12, fairly common when we were younger. Trend today is larger and larger formats with sizes up to 48 by 48 inch dust pressed tiles. We also have gauge porcelain tile, which can range from 3.5 millimeters to 12 millimeters thick, with facial sizes of 60 inches by 120 or larger. So you can imagine the need to accommodate movement joints is critical. But as tiles change, we have to adopt, and we've continued to make changes in our standards to accommodate this. Another industry you can see a lot of changes between is Jeep. 1945, 1984, 2018 Jeep, they all look similar, but vast differences. They're stronger, there's more horsepower, they're bigger, and so on. So, a lot more features. And same thing's true of our tile today. So we've got to accommodate for that. As I mentioned, we're going to get into a little bit on standards. Tile Council of North America, or TCNA, really, when it was first established, really had the sole intention of being there to expand the ceramic tile use in the United States. TCNA has been instrumental in the tile industry in developing installation standards and products. They also coordinate with manufacturing and installation professionals to write or publish the handbook and make recommendations for best practices and guidelines for installations of tile and stone. ANSI's also, TCNA is the secretariat for it as well. Separate operation, if you might, but they really do work well together. I kind of like to think of TCNA as the pretty drawings and ANSI as the plans on your project, right? So you got a set of drawings and you got a set of specs. ANSI's the specs, TCNA's the drawings. Let's take a good look at the standards for movement joints. ANSI in 108.1-3.7 lists the importance of movement joints. It says it's not intended to be a specification for movement joint recommendations. Design professionals are responsible to specify and detail movement joints and show locations. All openings for movement joints shall extend completely and directly through the tile work down through the structural backing. Movement joint design and spacing shall mirror what's recommended in TCNA EJ 171. That's Tile Council of North America Handbook, Method EJ 171. Now called movement joints, but You can imagine that EJ came from expansion joints. The first reference to expansion joints occurred in 1963 TCA book. In 1967, the title of that section was changed to expansion joints. In 1971, additional information was added on specifying sealants and spacings. In 1986, the method was titled EJ171. We continue to make changes, minor changes in expansion joint recommendations. This is the current handbook, and you can see in the bottom right-hand corner, there's even a formula for figuring out the need for the width of the movement joint on an interior installation. The accommodations or the spacing on it has changed from years ago to it continues to become, again, change and become a little bit more tighter, if you might. Some of the important parts of all the EJ171 is important, but let me stress some things to you. Perimeter and field movement joints within a tile installation are essential and required. That's in the handbook. This section provides general recommendations, guidelines, including the means by which movement joints and substrates are carried through and incorporated into tile installations. Because of the limitless conditions and structural systems in which tile can be installed, the design professional or engineer shall show specific locations and details of movement joints on the project drawings. Preparation of openings left by the tile contractor and installation of the backup strip and sealant should be specified in caulking and sealant section of the job specification. It's really difficult for a tile installer to understand the movement within a building. That's not their expertise. That's not what they went to school for. So it should be cooperative work. What I recommend to design professionals, especially on large commercial jobs, is request a shop drawing of where the movement joints should be. What I mean by that is they need to provide some guidance, but then in the end, come to an agreement through shop drawings on where they're going to be. Some of the basic guidelines in EJ171. On interiors, the maximum spacing should be no more than 25 feet each direction. This used to read, I think, 18 to 25, and we decided to drop the front end of that just because it's a range. It's just that. Exteriors, 8 to 12 feet in each direction, and that did not change. So we'll get into more details about the width of the joint and so on, and how that is affected by 8 or 12 feet on an exterior. Interior tile work exposed to direct sunlight or excessive moisture every 8 to 12 feet. In other words, you use the exterior recommendations interior. The reason for that is because, again, thermal expansion contraction or moisture expansion contraction. So an enclosed pool, that deck, you might have them every 8 feet. If that deck was outside, you wouldn't have to have it that tight. Above ground concrete slabs. So if you're looking at a second story slab in a mall, they again revert to every 8 to 12 feet in each direction. And perimeter joints. These are the ones that are always overlooked and are probably the easiest to accommodate and are essential to every movement joint installation. And they need to be clean, because the perimeter joints can sometimes go underneath a base, can frequently go underneath the base. They cannot be loaded up with mortar and dirt and electricians' wires and things like that. I know that never happens on jobs you're on, but just kind of throwing it out there. Changes of plane, interior as well as exterior. In EJ171 in 2020, we actually added this detail that you see here, which actually shows where the perimeter joints should go. Joints in the structure should continue through the tile work, including expansion, control, construction, cold, saw cut, isolation, and contraction joints, and seismic joints. Keep movement joints cavities open and free of mortar, dirt, grout, and debris. There is a note in there that says, if you decide to relocate a contraction joint or a saw cut by using crack isolation membrane, you cannot hold the tile contractor responsible for cracking in the grout joints or the tile over the saw cut. So if there's a not in plane movement, you can't hold the tile contractor responsible. They're talking about F125 in the TCNA handbook, which is really for cracking, but sometimes it's used for saw cuts as well. You should have a soft joint on each side of that joint if you do decide to bridge it and get permission from the setting material or membrane manufacturer. Many membrane manufacturers will allow for things like this, but you've got to check on a case-by-case basis, because today with large format tiles, F125 has two methods, partial and full. With large format tiles, there is no partial. You really have to do a full installation of it. So there's going to be caveats more than likely if you're going to do this. So I suggest reaching out to your setting material manufacturer and getting specific recommendations if you decide that you want to bridge saw cuts. I will also tell you that every setting material manufacturer will tell you that if you choose to, you still will have to use the same frequency of movement joints. In other words, if they allow you to bridge a saw cut, you're still going to have to place on the interior movement joints at least every 25 feet, and any protrusions through the floors and perimeter joints. I hope that's clear. And when I say I hope that's clear, when it is really a gray area, check with your setting material manufacturer. All right, let's talk about the joints themselves and joint width. On exteriors, they're minimum 3/8 of an inch for joints on 8 feet on center, 1/2 inch on 12 inch on center. Not only that, in addition to that, there are requirements for temperature changes. So if your temperature fluctuates more than 100 degrees between the hot summer heat and the winter low heat, then you should increase the width of the joint by 1/16 of an inch. Perimeter on interiors, perimeter joints at the walls should be not less than 1/4 inch, and they can be commonly covered by trim, cove base, and shoe molding. Perimeter joints other than perimeter walls preferred not to be less than 1/4 inch and not less than 1/4 inch and never less than 1/8 of an inch. Interior width can be calculated by formulas I showed you in the handbook. This gives you a little bit of an idea of some of the temperature changes between summer and winter. And if you're in the areas like LA, San Francisco, Miami, you really don't have to worry so much about this 100-degree rule. But if you're in areas of Atlanta, Georgia, or Chicago, New York, definitely you have to take a serious look at this. So you're exceeding well over 100 degrees from winter lows to summer highs. Talk a little bit about sealants. Commonly used ones are urethane sealants, using interior, exterior joints and horizontal interior joints, high abrasion resistance in traffic areas. Silicone sealants can be used on interior and exterior installations of tile. However, be careful if you're working with natural stone. Some silicone sealants can stain the stone. They'll actually bleed into it. Not pretty. It has to be tested before you consider using a silicone. Polysulfite sealants are the oldest technology and are very chemically resistant. The standard, by the way, EJ 171 really doesn't address polysulfite, but wanted to put it in here just so you had an idea of a change in one. A little bit more on the guidelines, or if you might, the standard for sealants. There are two standards listed. Standard ASTM C920, which is for elastomeric joint sealants, the product standard, if you might. And ASTM EC1193. That's the use of sealant joints, how they're installed, etc. You can have one that meets ASTM C920 and have a variety of different types of designations, if you might. Type S is a single component sealant. Type M is a multi-component sealant. Some of them come in two parts. Grade P is for joints on a horizontal surface. Grade NS is for non-sag. Class 25 is for the amount of movement it can occur in expansion and contraction, if you might. In other words, if the joint width increases or decreases plus or minus 25%, that sealant can handle that. Type T is in our standard, and we talk about it with a minimum shore hardness of 25 or better. So that's a traffic one. This is important if we're on a horizontal installation floor and you don't want somebody's heel to get stuck inside the sealant or anything like that. There's an NT designation for non-traffic exposures. And then there's also one that is an M and a G, so it bonds well to mortar and glass, glass being similar to tile. Again, preformed profiles are another way to look at it. And I will tell you one thing about these profile pictures. I'm not a big fan. The one on the left is fine because that's mechanically anchored. The one on the right is done through mortar, and obviously you really have to make sure that you bed that leg that's in the mortar well. So in other words, it should be covered with mortar well. Those are always done just for pictures. They are nice and graphic, but that's not how we want to see them installed. So in EJ 171, there is a large variety of details as well. And this one, you can see 3 different ways to detail an expansion joint at the location of the expansion joint in the substrate. In other words, this one is a true substrate expansion joint going all the way through the building or structure. On the left, you see one being handled with a backer rod. And you'll also notice that the sealant is shaped 2 to 1. In other words, it's twice as wide as it is deep. That's the way you'd like to see a sealant installed. On the one in the middle is got a structural joint backup. Could be like fiber mesh, you know, like you see in an expansion joint where a sidewalk meets a building or something like that. Cut down lower, and then there's bond breaker tape and or backer rod, and then sealant installed over that. And last is a compressible backer rod. And sealant on top of that as well. These are a couple different details for mortar beds. The one on the left is bonded. The one on the right is not bonded, shows a cleavage membrane and wire reinforcement, but the joints are typically about the same. Contraction joints, in other words, a saw cut, and that's not going all the way through the slab, or a construction joint, or cold joint. That does go all the way through. Perimeter joints, again, can't stress them enough. They're critical, and you can typically hide those the best. Perimeter joint with the mud bed, and again, the perimeter joint movement detail that we showed earlier. Natural stone with the bond breaker tape. In other words, not a backer rod, just a tape there to keep it from sticking to the back of the slab for that matter. Think about this. Let me explain this because some people don't quite understand why we have to have bond breaker tape. They just fill it up with joint with sealant and think it's going to perform. The joint cannot expand and contract if it's stuck on the bottom. It has to be almost free floating, if you might, bonded on 2 surfaces, not 3, in order for it to accommodate expansion and contraction. So that's the reason for the bond breaker tape. I've seen people use sand, anything to keep it from sticking to the slab. But most important, it can't stick there. You can't be filled up with just nothing but sealant. It does not perform. These are 2 different joints with backer board, just a generic joint, and then one over the structure, a movement joint. Again, that goes all the way through it, like I showed you with the mud bed. All right, let's talk a little bit about some of the things we covered. I think we covered a lot. What happens when we don't allow for a movement joint in tile installation? In most cases, lack of room for movement tends to create tenting or disbonded tiles. Types of joints are in concrete slab and how they function. You can see now that the substrate has and typically will have saw cut joints, expansion joints, cold joints, construction joints, and they all have the ability to move. Sorry, I had to cough. And last, what standards do you follow? Well, in this case, ASTM as well as TCNA, and ANSI standards. EJ 171, expansion joint 171 method is the most critical. It has as much detail as you could possibly want in it. I think if it's one place to go to, that's it. It's certainly a starting point. I don't know what it is today. It's probably a 8-page document. It's quite extensive with all the details and so on, or 6-page document in the back of the TCNA handbook. It is essential to tile, glass, stone, any of the tiles. GPT, by the way, follows exactly the same standards as EJ 171. The rule of thumb is to install a movement joint at the perimeter and in the field at least every 25 feet for interiors, every 8 to 12 feet for exteriors, or interiors when exposed to direct sunlight and excessive moisture, again, follow that 8 to 12 feet. I hope you found this helpful. We can't stress it enough. Those of us who are heavily involved in the tile industry, we see failures due to lack of movement joints on a daily basis. It's unfortunate we have these many pictures that show tile pop up and so on. What we don't show is some of the things the danger that really can occur. I had a good specifier friend of mine in Colorado Springs, and they put in a not a thin brick, but not a complete depth brick. I think it was 3/4 of an inch on the outside of the city of Colorado Springs City Hall, and in front of a parking garage. And he said they were standing there one day and it popped because they didn't have enough movement joints in it, and it went 8 feet in the air. So it blew out a large area. You don't need somebody standing over that in front of the city hall and something like that occurring. I was in a mall one time in Pueblo, Colorado, and I was there by chance. And I was on a job review with another installer in a different building, totally different business. And he said, "Do you mind if I stop at the mall? I got to see my guys real quick, and just stop in 5 minutes and be gone." I said, "Sure, sure, sure." So we stopped in the Pueblo Mall, and we're standing there, and what the guys were doing is they were lifting out a 30 by 30 area, removing all the tile, reinstalling it, and putting in proper movement joints. In other words, all the tile had failed. They knew it was hollow and it failed, but the reason it had failed is because of movement, and they were putting it back in, and then of course putting sealant in some of the joints. Well, while we're standing there in the middle of the mall talking to the installers doing this project, a security guard came up to me and he said, "Sir, would you come with me? One of the store owners says he thinks you took something from his store." Well, being cocky as I am and knowing that I had not been in a store yet, I said, "Of course I will." And I walked with the guy, and I walked into a baseball card store, and an old tile setter owned the baseball card store. And he started laughing as the security guard brought me in because he was playing a prank on me. Well, me and Bill were talking about it and said, "Wow, you know what a shame having to do this all throughout the mall, take out different sections and reinstall it." They literally go in piece by piece all the way through the mall. He said, "Yeah, I've been watching him do it for a long time." And Bill, by the way, used to do a lot of commercial type tile installations, now in the baseball card store. So talking to Bill about it, and all of a sudden the security guard says, "Hey, I got a story for you." He said, "I was standing at one end of the mall one time, and I heard a gunshot go off at the other end of the mall. So of course I ran down there, turned into an alcove, and there was nobody there. But there was tile 30 feet up in the ceiling. It was restrained on all sides by brick. The tile expanded, had to relieve itself. It couldn't. It literally popped, and tile ended up in the ceiling tile. Not safe. This doesn't have to happen. Please put your movement joints in, even as simple as your backsplash to the countertop, between walls in the shower, floor to wall, perimeters, and throughout the field. It's essential, it's critical, and you may not see the failure because sometimes they occur many years down the road, but it will fail. Thank you. I hope you learned something from this presentation. I appreciate you giving me the opportunity.
Jim, what a great job. And attendees, I want to thank you all. Right now, there was 115 attendees today. And in the chat screen, the questions area, I did put my email address. If you're looking for your CEU, AIA CEU, please send me an email. We'll get that out to you right away. Jim and I will. That was great. Jim, fantastic. The pictures to go along with your explanations were fantastic and really helped a lot. I think that's great. And we do have some questions. I'd love to go through these questions with you. If you're okay, we can start right now. All right, we're going to start with some easy ones. All right. Do grout lines have to line up with the movement joint?
No, not at all. But I think they typically want to. I mean, I think you want them to look the same. So this question comes up sometimes about like exteriors where they're recommending a 1/4 inch width. Gauge porcelain tile does not look the best with 1/4 inch width joints everywhere if you decide that you're going to put it up with nothing but sealant. But it could be the minimum thickness, whether it's 3/8 or whatever, or 1/4 inch in the movement joint, and then have a tighter joint throughout the field. But that just generally doesn't look the greatest. So they do not have to, though.
I agree. They tend to look a little bit better, but they do not have to. All right.
Yeah, and one other thing I should mention is sometimes tile installations are put in, and they'll come back and they'll cut the joints in.
Correct. All right. So we have a business owner. He owns a grout medic business, and he said many times he's out and he sees showers, and in the corners between the two walls, the left and right walls, or what you would say vertical walls, they're grouted solid with no accommodation for movement joint. And what he's asking is, what should be used in those corners? And what he means is, should it be caulked? Should it be grouted and then caulked over the grout, or should it be a caulk or you know, we see this all the time, right, Jim?
Yeah, it comes up all the time. So it's a great question. I think that's kind of let me explain my preference. My preference is to have sealant in there first and then come back and grout to it. And that means it's got to set up and cure. A lot of people don't have the patience for that. And so they'll go in and grout. But the only thing, I have no problem with the grout going in first, but the joint has to stay open and clean. Can't stress it enough. In order for that movement joint to perform properly, it has to stay open and clean. And then, so if you have the tile grout in there and then you come back later to put sealant in there, it's usually a little bit easier because the grout sets up fairly quickly. But the sealant, you're going to end up having to wait for that to cure way before you're going to be able to put the grout in.
Let me just be clear, Jim. Let me just be clear on that. You're not saying grout the actual movement joint area. You're saying the walls can be grouted, but you have to leave that area completely open, and you can come back later to put the caulking in there.
The field can be grouted, but the perimeter and the movement joint areas have to be left open and clean. Yeah, good. I'm glad you said that. Really good comment. But yeah, it really, I can't stress enough, it has to be clean.
Perfect. We do not want grout in that area and then caulk over it. Okay, that we don't want. We want it clean.
Unfortunately, that's what we see a lot. You know, we see not grout there so much, but mortar sticking up. I had a project in southern Florida that had 18 by 36 inch concrete tiles, I'll say, and they're like a terrazzo type tile, and the joints were 3/4 of an inch mortar and a little bead of sealant over the top. By the way, the reason I was on that job is it was failing, and it was on a retail store, and it was failing right over the sidewalk. Dangerous as heck. So they had to shut down the sidewalk and not allow people to walk through there even because it was on the exterior. So, I mean, it needs to be a full depth joint of sealant with backer rod, you know, properly installed.
Great, thank you. All right, in an exterior all tile pool with running bond 2 centimeter limestone slab, does EJ 171 require 3/8 inch movement joint to continue completely through the concrete gypcrete shell and exactly align with the joints? That was a lot. Did you understand that?
Ooh, kind of, maybe. So movement joints in the go ahead.
No, if you have an answer, go ahead.
Well, I think let me try and answer it. I think movement joints in the structure have to be carried through the stone as well as all the way through, and there will be typically in a pool. Additional joints can be installed and are commonly installed in tile installations where there's not a true building movement joint in the structure. And again, that's done through backer rods and sealants in order to allow for the tile and or stone to expand and contract. I hope I got that right.
So John, if you have more question to that, please type it in and we'll get to it in a little bit here. Thank you. All right, here's a good one that I never even thought of. If grouting with a urethane grout, can that be used in the expansion joint area, or do you need to use a different type of caulking?
So the material that needs to go into a movement joint has to meet ASTM C920. And I'm not aware of any of those that meet that. So I will say it has to be a different material, a caulking. And we manufacture a variety of different single component premixed grouts, and we have sealants to match all of them, including our 3D line. So we believe strongly in the sealants being correct.
Great, great. So it has to definitely meet the requirements and at this point, we don't think the urethane grouts meet those, correct?
Correct.
All right. All right. All the sealant guidelines have letters that go with the specifications except grade P. Where did the letter P come from and what does it stand for?
P is horizontal, and I'm not sure what it stands for.
Okay, horizontal. That's good enough for me. I think it would work for Alice. P means horizontal. Great. Are there any standards to follow for a yacht or mobile home, or are they the same as a permanent structure? That's a tough one.
So we actually have a marine division. We have a variety of lines that we sell to cruise lines and large ships, yachts, etc. And we have a whole division for that. And I will tell you that it meets the exact same standards. Doesn't mean they do it, but it meets the exact same standards. There's no other recommendations. Now, granted, a lot of cruise ships, for that matter, are built in other countries, Italy, France, Norway, etc. So they're probably going to follow their local standards, but whatever those are. I mean, I know that Europe has movement joints as well.
So this is to Alice. Alice, one thing we didn't say is that manufacturers' recommendations supersede TCNA. And if you have a question on that, I think it would be great if you contacted your study material company. I'm sure Mapei would absolutely love to answer any of your questions. So
we're glad to. We're glad to.
Yeah, definitely. All right. Can you elaborate on using isolation membranes and backer board for managing movement? Do we use those for managing movement?
I'm not sure I understand the backer board part at all. Right. I mean, if you had a movement joint in the building, it would have to be carried through the backer board, literally separated there. Other than that, I'm not sure how else to address backer boards. And the other part of that was what, Jim? Backer board?
Using isolation membranes and backer board for managing movement.
So there's no standards for that. The TCNA handbook and ANSI are very clear. You just follow TCNA and ANSI, and there's no recommendation or accommodation for movement joints, because you're going to put a crack isolation membrane in there. But as I touched on, years ago when we used to, let's say we had a saw cut in the slab, and somebody come to us and say, we don't really want to cut our tile where that saw cut is. Do we have to? You might say, no, we've got a crack isolation membrane that you can go over that saw cut with. But the problem is you can't really make that as a standard recommendation today at all, because tile types are so different, concrete slabs are so different. Large format tile really plays into it. In other words, a 12 by 12 tile being offset off of saw cut, going out 18 inches each side of the joint was what we used to recommend, a tile and a half width each side of the joint. Well, with a 2 by 4 tile, you're not really going to go out 6 feet each side of the joint. It's not practical. So that recommendation we used to have it can only be, in my opinion, suggested on a case-by-case basis, and your setting material manufacturer would have to recommend that. I no longer recommend doing anything like that unless you've got full coverage of the crack isolation membrane. And again, you have to use the same frequency of movement joints. In other words, you still have to have movement joints every 25 feet in an interior. Just because you put a crack isolation membrane down doesn't eliminate that need.
Great. All right. Fantastic. All right. Somebody just wanted you to know great information, Jim. Always great to have a refresher, and he loved the pictures, so that's fantastic.
Oh, cool.
Thank you, Larry.
Sorry I get so many pictures.
We like pictures.
I know it
Are
does.
there any problems with? I'm sorry.
I just want to say, sorry. It's unfortunate we collect so many pictures. In other words, there's that many failures, and there's many more that we don't get pictures of. You know, that's the sad part of it. But I know it does serve a purpose and helps you visualize what's going on.
Yeah, actually, I have some video, unbelievable, of a lady in her residential home. She started hearing noises and turned her camera on. She didn't even know why. And all of a sudden, the floor started tenting and tile were popping up and hitting the ceiling 8 feet high. So, yeah, definitely it happens. All right, here's another one, Jim. Are there any problems with grinding or brushing down curled concrete to make it flat for the tile installation?
It would depend on the age of that concrete, I think. As concrete is not my expertise per se, I'd say really the engineer should answer that question on the project. But if it's new concrete, I'd be concerned that it's going to continue to shrink as it cures, and you're going to have a different profile once your tile set and it dries out. So I think there could be potential problems with that, definitely. I think minor ones that have been there 20 years, I'd do it in a heartbeat. But if they're new slabs, that's a whole different animal. And I think a structural engineer's got to address that, or the design professional.
Very good response. So I hope that answers Randy. Jim, that is all of our questions today. This was very educational. You can tell it's good. Over 105 people stayed with out of 115 to see these, listen to the questions and to see what your answers are, listen to your answers. So fantastic. Thank you, everybody. Please look forward to our next webinar. An invite will be coming out early August for August, I think 23rd, hold on a minute, August 16th will be our next webinar. So thank you, appreciate it. Again, we've had a few people already reach out for their CEU, and send me an email, it'd be great.
Thank you guys very much, appreciate it.
Bye everyone, thank you.
Bye now.